Greetings, everybody. So here's the question I got today, and I think it'd be good to answer it by making a video. So here we go. The question is about deciding ultimately if this series converges or not. And we'll use something called the limit comparison test. And it says that we're going to compare with this other series. See this one right here? Okay, so here's how this will work. The limit comparison test says we've got two series, and I'll call it A and B. And we make a decision about whether the series in question converges by calculating this limit. Okay? And we'll get some number L, whatever it is, from calculating that limit. And then we'll make our decision based on these three cases you see here. All right. So the way that translates to us is that I've got to take this expression, n minus 4 over n third minus 2n squared plus 7, divide by this one, 1 over n squared, and figure out what that limit is as n goes to infinity. All right, so let's talk about how you'd find this limit. Because me knowing this limit and then referring to these cases over here is ultimately how I decide whether the series in question converges or not. Now, I think there's a little algebra that's needed to reduce this before we start worrying about the limit. And I see that I'm taking one fraction, I'm dividing by another. I can multiply by the reciprocal like this, distribute n squared upon n minus 4 and get this. Okay, so my limit is going to be this. All right, now let's talk about how we would do this limit. If I let n go to infinity, then I see individually both of these expressions on top and bottom go to infinity. So this is called an indeterminate form, infinity over infinity. We use something called L'Hopital's rule to evaluate limits like that. Here's how L'Hopital's rule looks. It says, let's see, right here, it says if you have the limit as your variable goes to infinity as of some function f over some other function g, and then both of those individually are infinity, then we can reevaluate that limit in terms of their derivatives. So I can find, instead of what's the limit as x goes to infinity of f over g, I can find what's the limit as x goes to infinity of f prime over g prime. So I'll do that. It's called L'Hopital's rule. Okay, so here's L'Hopital's rule. Take the derivative of each of these, top and bottom, individually. I get 3n squared minus 8n over 3n squared minus 4n. That, me doing this one time, is still infinity over infinity. So I repeat L'Hopital's rule. The derivative of this individually is 6n minus 8 over 6n minus 4. That's still infinity over infinity. I repeat one more time, take the derivative once more. I get 6 over 6, which is just 1. And then 1, I mean, I've got a definitive answer at that point. 1 is our limit. Now, that's L'Hopital's rule. If this is the part you're getting stuck on, as far as on what basis do we calculate this limit, then L'Hopital's rule is what I would appeal to. Okay, now, well, let's see, what does that mean? We were supposed to figure out what this limit was, and I got 1 was the answer. So which case is this? I didn't get infinity. I didn't get 0. I got some number L, which was 1, which is a finite positive number. So we're in case 1. Case 1 says, okay, then those two series, the one that you had and the one that you were comparing with, either both converge or both diverge. Okay, so how we make our decision is this. See that one we were comparing with? Does it converge or diverge? Because whatever it does, ours is also going to do. That's what case 1 says. So what is this series 1 over n squared? Like, what do we know about that? It does converge, but on what basis would you say that? Okay, well, that series 1 over n squared is a p-series. Okay, a p-series is a series where it's 1 over n, the variable in your series, to some power p, which converge if p is more than 1 and diverge if p is 1 or less. So we had 1 over n squared, that makes that power 2. So the series 1 over n squared converges because it's a type of p-series that converges. So that's the basis where I say, okay, that series we were comparing with converges, so does ours. So does the one we were starting with. Okay? All right. That's what this case one says. They both converge or both diverge. Now to fill in all the blanks, that's our ultimate answer. That series AN, this one here, the one we were given to decide about, converges because that limit from the comparison test was 1. The terms of the series are all positive. Notice that's just built into the fine print of the test, that the series you're working with have to have all positive terms. And they do in this case. Once you get past 4. And so BN also converges, right? That was a P series. So that's how, like, I can take my page of work. Here's all my thinking, all right? And my reference to the limit comparison test to select all these answers. Okay, so anyway, hope that makes sense to you. And it may be that you just get stuck on one element of this, such as reading through this and understanding the cases, or knowing how to calculate the limit by L'Hopital's rule, or maybe even the algebra. Whatever the case is, if you still get stuck with it, let me know and I can help you out.